Hey guys, I'm going to teach you how to do dilations on the coordinate plane. By the end of this lesson, you'll be able to use scale factor to make an object bigger or smaller on the coordinate plane. So go ahead and get your binder, turn to the math section. Let's go ahead and take some notes. First of all, a dilation is when an object either gets bigger or smaller. If an object gets bigger, we might say it got 2 times bigger or 3 times bigger. And we're using the word times. That's because to dilate a figure, we always multiply, we times, by the scale factor. And the scale factor is like that 2 or that 3. That's 2 times bigger. We'd multiply each coordinate by 2. If it was 3 times bigger, we'd multiply each coordinate by 3. When an object is dilated and it gets bigger, that's called an enlargement. That means that the image will be bigger than the pre-image. For example, if you had a point at 2, 5, and the new shape was 2 times bigger, you'd multiply each one of these points by 2. So after the dilation, the new point would be at 4, 10. You always multiply by the scale factor. However, like I said, dilations don't always make objects bigger on the coordinate plane. If your scale factor is less than 1, you call that a reduction, and the image will then be smaller than the pre-image. Now, when I talk about scale factors that are less than 1, I'm not talking about negatives. I'm talking about fractions and decimals. Those are numbers that are less than 1 that would shrink your object. So, for example, if your scale factor was a half or a third of the size, you would multiply each of those points by that fraction. You could also see scale factor written as a decimal. If the scale factor was 0.25, that's the same thing as a quarter or a fourth of the size, and you would still multiply by the scale factor. So if we use our example from earlier, if your point was at 2.5 and there was a reduction, you would multiply by 1/2 and you would get the new point 1 and 2.5. In both of these examples with a reduction and enlargement, we multiplied by the scale factor. If you're given the scale factor, multiply by it, and you do that for each of the points. However, you're not always given the scale factor. If a dilation has occurred on the coordinate plane, you can find the scale factor by choosing corresponding sides, which means matching sides, and then set up a ratio. You can set up your ratio new side over the original side, or you can think of that as the image over the pre-image. That ratio will give you the scale factor. All right, so keeping all that in mind, it's time to practice it. Let's start with our first example. It says dilate the rectangle shown by a scale factor of 1/3. Record the coordinates in the table. We're going to put our coordinates for the pre-image here and then the image here. So let's go ahead and start by finding our coordinates in the pre-image. I can see if I'm looking for point A, I'm going to go over 6, so it's -6 up 3. So my ordered pair is -6, 3. Remember, it's X before Y, walk before you fly. Go ahead and plot the remaining points in the table for the pre-image and then press play when you're ready to check. All right, so now we've identified all the coordinates for the pre-image. Now it's time to dilate the rectangle. It tells us that we're going to dilate by a scale factor of 1/3. Right away, I can tell you something about that 1/3. I know that my new image is going to be smaller than the pre-image because 1/3 is less than 1. This is a type of reduction. I also know that since I'm given the scale factor and I have all my coordinates, I need to do something with that 1/3. I know I need to multiply by the scale factor. So I'm going to multiply one point at a time. Here's what I mean by that. I'm looking at point A. I'm going to look at just the X coordinate, -6. I'm going to figure out what 1/3 of -6 is. 1/3 of -6 or 1/3 times -6 is -2. That'll be my X coordinate. I'm going to do the same thing for my Y coordinate. I'm going to take 1/3 of 3. 1/3 times 3 or 1/3 of 3 is 1. So now I have my new coordinate for A. The image of A will be at A prime, -2, 1. So then I'll just plot that point on the coordinate plane. Now we're going to want to do that for each one of these points. So we're going to take 1/3 of 6 for the next one. 1/3 of 6 is 2, and 1/3 of 3 is 1. So now I have 2, 1, my new point for B prime. I'm going to go ahead and plot that on the coordinate plane. Go ahead and try that, multiplying 1/3 the scale factor by each one of these points for C and D, and tell me the new points. Press play when you're ready to check. All right, so we should have these new points. We can go ahead and plot them on the coordinate plane. And then last step, we just connect our points. Again, we got this new image by multiplying by the scale factor. But there's a couple of cool ways we can check this. The easiest way I can check this for me is that I know that I multiplied by a number that was less than 1. This is a reduction. Does the new rectangle look smaller than the original rectangle? Yes, it should. It was a reduction because it got 1/3 of the size. Another really cool way to check this is to look at corresponding sides. Corresponding sides are matching sides. Let's look at A to D and then the new A to D. Starting with our image, I can see that the new A to D is 2 units long, and I know that the big one is 6 units long. I can count it. 2 over 6 simplifies to 1/3. That same thing will work for B to C, and this little B to C, still 2 over 6, which makes 1/3. So let's look at the ratio the other way. From the new A to the new B is 4 units long. In the pre-image, the A to B is 12 units long. And if we look at that again as a ratio of the new to the old, that also simplifies to 1/3. So this is just another way to compare those ratios, those corresponding sides, and check. We should notice that they all simplify to 1/3, which was our scale factor. We can represent what we did algebraically. Since we did 1/3 of the x, 1/3 of the y, we would write that as a coordinate and put 1/3 next to it. That means times. And then the last thing, since we dilated the images are no longer congruent. Instead of being congruent, they are similar. Similar figures have the same shape but different sizes. They'll have the same orientation. They're facing the same way. And they'll even have the same exact angles. However, they'll be different sizes. They'll be proportional but not equal. All right, so keeping all that in mind, let's go ahead and look at another example together. And this time we're going to dilate by a scale factor of 2. We're going to then record the algebraic representation of this dilation. Let's start like we did last time. Let's go ahead and plot the points for the pre-image. Go ahead and try that now and press play when you're ready to check. Here are all the points for the pre-image of this trapezoid. Now we need to go ahead and do our dilation. We're going to use each coordinate, and we're going to use the scale factor of 2, and we're going to multiply, because we always multiply by the scale factor. So for the first one, I'm going to go ahead and take the -4, multiply it by 2. The 2 and multiply it by 2. What will be my new point? -8, 4. And then we can also plot that onto the coordinate plane. We're going to do the same thing for point F. Since the whole figure needs to be 2 times bigger, we're going to do 2 times for each point. So the new point is at 8, 4 for F prime, and then we can plot that on the coordinate plane. So go ahead and try finding the new point for G and H all by yourself, and then press play when you're ready to check. All right, so now we got all our points. We got them plotted. We can go ahead and connect them to form our new image. At this point, you can probably tell me a few things about the similarity between these two figures. I can tell you that the side lengths are proportional. I can tell you that the angles are all the same in these two similar figures, and the orientation is the same. However, the side lengths are different. They're not congruent. They're the same shape, but different sizes. That's what similarity means. I also can tell you the algebraic representation for this dilation. Since we doubled the x and doubled the y, we would just put that times 2 in front of each one of those coordinates. All right, so I got you started on number 5, then you're going to do the rest by yourself. It says dilate the figure by a scale factor of 3/2, then record the algebraic representation. So your first job is to go ahead and find the coordinates for the image. Go ahead and do that now and press play when you're ready to check. All right, now that I have the coordinates of the image and looking at your scale factor, does this dilation represent an enlargement or a reduction? As you can see, the image got bigger, so it's an enlargement. For the algebraic representation, you could have written that as 3/2 x, 3/2 y, or as a decimal, 1.5x, 1.5y. It's 1.5 times bigger. All right, for the next two examples, we're not given the scale factor. Our job is to find it. So we're going to find the scale factor in each of these pictures. I'm going to go ahead and look at number 6 with you. First off, I know that if I'm not given the scale factor, I need to go ahead and write a ratio of the image over the pre-image, or the new over the original. So I'm going to go ahead and find my corresponding sides. Looking at the new image, has that little A prime or B prime, in this case M prime and N prime. I can count that that's 5 units. Now I want to find its corresponding side. So the original M to N, and I want to count how many units that is. It's 4 units, so my ratio is 5/4, or 5/4. 5/4 is the scale factor, so this is an enlargement. The new triangle is 1 1/4 times bigger, or 1 1/4 times bigger than the original. So go ahead and try that for number 7. Keep in mind the image over the pre-image is the ratio. Our scale factor needs to be new to old. And the little triangle in this case is the new triangle. I know that because it has those little prime symbols on each one of the points. So you could have put 3/9 or 1/3. Either one works for this example. So if scale factor is just a ratio of the new image over the original, we don't even need the shape drawn for us. We can just see it in the points. Number 8 is our first example of this. The new point is at 6 and the old point was at 9. Those are the matching x coordinates. 6/9 reduces to 2/3, and that's our scale factor for this example. You could have done the same thing with the y-coordinates. 8/12 also reduces to 2/3. All those are the scale factor for this dilation. Go ahead and do that for number 9 and tell me what is the scale factor for this dilation. You could have used the x-coordinates or the y-coordinates, and you might have got thrown off by the negatives. It doesn't matter. A negative divided by a negative is a positive. And whichever fraction you use, your ratio would be 6/5. 6/5 is the scale factor for this dilation. Try the last one all by yourself. All right, so looking at the last one, if I did -9 over -1, I would have got a scale factor of 9. You can see that it's times 9 to get to the next point. If you got thrown off by this and you tried, okay, well, 0 divided by 0 is 0, so can the scale factor be 0? I'll tell you right now, the scale factor will never be 0. It's always going to be greater than 1 or less than 1, but we're really not going to see scale factors as negatives. We're not going to see them as 0. I am curious what you think. One last question. What do you think would happen if the scale factor was 1? If the scale factor was 1, the pre-image and the image would stay the same. All right, guys, that's it. If you made it to this video, I want to know if you could make yourself 4 times as big or 1/4 of the size, which would you choose and why? Today, we learned all about dilations on the coordinate plane. So now you should be able to use scale factor to make an object bigger or smaller. So go ahead and go back to the calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye.